So good morning. Today we're going to go over 4.5. The first couple things I want you guys to know is this part right here, which is solving simple exponential logarithm equations. Some of the rules. So for example, if you have an equation that's 2x equals 32, 2 to the power of x equal to 32, you can rewrite it with exponents as it shows right next to it. 2 to the power of x equals 2 to the 5th. And you can just equal the x's to the exponent. Same thing happens with the logs. If you happen to have two logs, you don't have to necessarily always divide them, even if they are a subtraction. Notice they are the same base. So if you happen to move the log 4 to the 8 to the right side, we can ignore the log 4 and just equal the x to the 8. Same for this. When we have an ln for both, the ln's can be ignored and we would end up with a 3. Same with the exponents. If we make this into 3 to the negative x, and 9 we put it to the 2, we can say, well, that x is going to be equal to negative 2. Those are all called a one-to-one property. So that means that if you happen to put them in the same form, the same base, and the same everything, you can ignore the thing that is exactly the same and just equal the x to what's remaining. And then you have stuff like the inverse, which is e through h, which if you have ex, the inverse of e is ln. So the inverse of e is ln. So if you put an ln on both, so we put an ln right here and ln right here, you can cancel those out and you will be left with x equals ln of 7. The ln and the e were kind of like the square root and the square. They cancel each other out. Same for the next one. We have ln x equals negative 3. If we add an e to it on both sides, we can cancel the ln and we're left with x equals to e to the negative 3. Same for the logs. If we have log 10 of x. If we add a 10, because it's the same base, we can cancel it out and we get x is equal to negative 1, which is just 1 over negative 10. Same with the other one. We have log 3 of x equals to 4. If we add a 3 for the base, the log cancels out. And you're left with x is equal to 3 to the 4th power. Now, this is also has to do with 4.3, which is how you rearrange the log equations. Now, the strategies used in example 1 are summarized as follows. So, we have step 1, which is rewrite the original equation in a form that allows to use of the one-to-one property of exponential or logarithm functions. That is the one I prefer to use whenever possible, just because I can ignore part of the equation and it makes it a lot easier to get the final answer. Number 2 would be to rewrite an exponential equation in logarithm forms and apply the inverse property of the logarithm function. That one is great as well, as you can cancel stuff out. I just prefer one because I can cancel things from both sides. It's not always possible, but it is very useful as well. And then number 3 is rewrite a logarithm equation in exponential form and apply the inverse property of the exponential function. Again, 2 or 3 are kind of the same thing, just one is going towards the logarithm and the other one's going towards the exponential. But they are the same thing, just inverses of each other. Now, for example, we have a couple of questions that we want to solve. We have A, I'm going to rewrite it down here, which is ex is equal to 72. Let me rewrite it a little bit further away. So we have ex equals to 72. Now the inverse of e is going to be the ln. So I would be adding an ln to both sides, kind of multiplying it. This would allow to cancel out the ln and the e, and you're left with x is equal to ln of 72. Now you have a button in your calculator, which is the ln button. You would press it to find the ln of 72, and you would get your x to equal 4.277 as your final answer. For B, we have 3 to the x power equals to 42. Now, since I'm solving for x, the first thing I'm going to do is try to isolate whatever has the x, which is, in this case, we'll be just dividing by 3, just like usual. Now we're left with 2 to the x power is equal to 14. Now, if you guys remember the rules of logs, I can actually add a log for both of these. So I could do log 2 to the x power equals log 14. But then remember, this exponent we can bring to the front. So we're left with x log 2 equals log 14. And when I move that exponent to the front, I'm able to now divide log 2 on both sides. And after I plug that into the calculator, actually, let me write down this first step. X equals log 14 over log 2. And then after plugging it into the calculator, we're left with x is equal to 3.807. So now example 3, they still want us to solve it. We have this equation. I'm going to go ahead and write it first. 4e to the 2x minus 3 is equal to 2. The first thing I'm going to do is try to get the term with the x by itself. So I'm going to go ahead and add the 3 to both sides. When I do that, I get 4e to the 2x power is equal to 5. Afterwards, I want to make sure that e to the x power is by itself, so I'm going to divide it by 4. And we get e to the 2x is equal to 5 over 4. Now, I can get rid of that e by adding an ln, so I would have to add an ln to both sides. That will cancel my ln and my e. So I would be left with 2x is equal to ln 5 over 4. Now I have one more step, which is divide by 2, and divide the whole thing by 2. So you're left with x is equal to ln 5 over 4. This is how you would plug it in the calculator. You would let me write it down as if it were the calculator. You would do ln in parentheses 5 divided by 4, close parentheses. You would hit enter, and whatever your answer is, you would then divide by 2, and you would get your x to be 0.112. Okay, so here we're going to go to example 4. We have this equation, 2 parentheses 3 to the power of 2t minus 5, and then minus 4 is equal to 11. We're going to go ahead and add 4 first on both sides. So I'm going to be left with 2 times 3 to the 2t minus 5 power equals 15. All divided by 2, divided by 2. It's going to be 3. 2t minus 5 equals 15 over 2. Now I'm going to add the logs on both sides in order to simplify this. So I would get log 3 and then 2t to the minus 5 equals log 15 over 2. I can bring the exponent to the front, and then I will get 2t minus 5, and then log 3 equals log 15 over 2. I will divide by log 3. Keep going up here. I'm going to be left with 2t minus 5 equal log 15 over 2 over log 3. I'm going to go ahead and add the 5. And left with 2t is equal to log 15 over 2 over log 3 plus 5. I'll then divide by 2, but I'll divide the whole thing by 2. So when you plug it in the calculator, make sure you plug in log 15 over 2 divided by log 3. Hit enter. After that, you would do plus 5. Hit enter. Then you would do divided by 2. You would hit enter, and then you would get t is 3.417. Okay, so we have example 6. I'm going to go ahead and write A up here. So we have ln of 3x equals to 2. The first thing I would do is add an e for both of them because the e and the ln cancel out. So we're left with 3x is equal to e to the second power. Then I'll divide by 3, and you would get x is equal to e to the second power. This is how you would do it on your calculator. you do the second power, and then you would hit the divide button by 3. You would get x is equal to 2.463. Now for b, I want you to notice how we have a log 3 and now we have a log 3, and they're both on different sides. So we can just actually go ahead and cancel them out, and we're left with 5x minus 1 is equal to x plus 7. I'll then subtract the x, and I'm left with 4x minus 1 is equal to 7. I'll add 1 to both sides, and we get 4x is equal to 8. I'll divide by 4, and we get x is equal to 2. So example 7, it says to solve this equation, logarithm equation, we have 5 plus 2 ln x equals to 4. First thing I'm going to do is subtract 5. So I'll get 2 ln x is equal to negative 1. I'll then go ahead and divide by 2, and we get ln of x is equal to negative a half. Now in order for me to get rid of this ln, I would do an e on both of these. So the e and the ln cancel, which will leave me with x is equal to e to the negative half power. I plug that into the calculator, and I get x is equal to 0.607. It's telling us to solve the logarithm equation. They want us to solve this 2 log 5 3x is equal to 4. First thing I'm going to do is divide by 2. So I'm left with log 5 and then 3x is equal to 2. Now remember, when we saw in the very first slide, we would look at the base. In this case, our base for this log is 5. So I'm going to erase everything. I'm going to make a base for everything of 5. So that way I can get rid of my log on the left side. So I'm left with 3x is equal to 5 squared. So it's going to be 3x is equal to 25. I'll divide by 3 on both sides, and we get x is equal to 25 over 3. So here we want us to solve it, and they want us to check for the extraneous solutions. Now notice they're all ln, so I'm going to actually use the properties that we learned yesterday to combine everything that I can in order to cancel out the ln's. So I can do that because this is addition. I can multiply them together, and I can grab this 2 and put it as the exponent. So I'm going to write ln x minus 2, 2x minus 3 is equal to ln x squared. Now I'm going to go ahead and FOIL the x minus 2 and the 2x minus 3. And I would get ln is equal to 2x squared minus 7x plus 6 is equal to ln x squared. Now if you guys remember, the ln's can be canceled out with an e. So we can cancel them out. Again, if you notice that they are the exact same thing on both sides, you can also just ignore them because we simplified everything. I just put it to the e or erase everything from the e base just to match the notes. So I end up with 2x squared minus 7x plus 6 is equal to x squared. I'm going to go ahead and subtract the x squared on both sides. So I will get x squared minus 7x plus 6 is equal to 0. Now I'm just going to factor this problem. So I'm going to get x minus 6, x minus 1 is equal to 0. So each parenthesis, we're going to equal it to 0. So we get add 6, we get x is equal to 6. We'll add 1, x is equal to 1. So these are both of our solutions. Now, they asked us to check for the extraneous solution, so I'm going to check here. The first thing I'm going to check is x is equal to 1. So I'm going to do ln 1 minus 2. All I'm doing is plugging the 1 into the original equation. we are left with this equation. Now I'm going to simplify everything that I can before. So we get ln of -1 plus ln of -1 equals 2 ln of 1. I can combine these two because they are the same on the inside and the outside, so I can say it's 2 ln of -1 equals 2 ln of 1. Now, -1 and 1 are not the same, so because they're not the same, this is considered an extraneous solution. I have to check the other one, so I'm going to check x is equal to 6. So I'm going to get ln 6 minus 2 plus ln 2 times 6 minus 3 is equal to 2 ln of 6. Now this is going to simplify to ln of 4 plus ln of 9 equals 2 ln 6. I plugged this into the calculator and I got 3.58352 equals 3.58352, which is the same, so therefore your only real solution would be x is equal to 6. So let's do example 10. So we have 2 e to the 2x power minus 9e to the x power equals 5. Now, for this type of problem, I'm going to move everything to the left to equal to 0. I don't know if you noticed, but because we have the e to the 2x, the e to the x, and then a 5, this is basically, it's basically a quadratic equation. So we're going to use substitution to make our life a little easier. I'm going to say that y is going to equal e of x. So I can say, well, 2 y of 2 minus 9y minus 5 is equal to 0. We're going to look for the factors of 10 that add up to -9. The only ones that do that is 1 and -10. And because we're looking for -10, it works out. So I'm going to go ahead and do 2y plus 1 and 2y minus 10 is equal to 0. I'm going to now equal each parentheses to 0. So we get 2y plus 1 is equal to 0. And then 2y minus 10 is equal to 0. Minus 1 first. So 2y is equal to -1/2. Sorry, y is equal to -1 divided by 2. Y is equal to -1/2. Now I'm going to add 10. And we get 2y is equal to 10. I'll divide it by 2. Divide by 2, and we get y is equal to 5. Now you do have to check to make sure that this works. So I'm going to grab this equation that is what I wrote down to make something a little easier to solve, and we're going to check it down here. So if we do e of x is equal to -1/2, if we do the ln on both sides, you're left with x is equal to ln of -1/2. If you plug that into the calculator, you will get an error message because a negative ln is not possible. And then we would try it also for this one. So it's going to be e of x equals to 5. We're going to do the ln to cancel out the e. So we're left with x is equal ln of 5. When you plug that into the calculator, you get an actual number, which is 1.609. So your solution will be 1.609 because the other one is not possible.